Hello Calculus fans, making a video on work, as I mentioned in the previous video where I did what I would call leaky bucket problems. I've done a lot of these sorts of problems already. Check my notes, I did. So if you look at my lecture notes, you can see many examples. That was section 6.4, where I talked about this approach of stacks of books. I explained my thinking. I did some examples. We did pumping examples. So we've done a large collection of these, and then I have examples here, practice examples with solutions. I have extra practice with solutions. I have super challenging questions with solutions. I have a test prep with a video solution. So there's been a lot of stuff, but at the end of the term, students are asking me about it again. So let's do one last crack at this, making the assumption that we've done a little work with it, and we are now going to just practice on some old exam questions. So they give us this unusual tank, and they say X is arc sine of Y is rotated around this to form a container. It's filled with liquid. It mentions the work. So the moment you see this, you should think about stack of books. There's one book. I like to think of it. And there's another one up here. And there's another one down here. And we would like to lift this to the top, and lift that to the top, and lift that to the top. And your job is to find the pattern. What does that look like? So you label this Y, you have to, and the rest of the stuff you can almost fill in automatically. What do I mean? Y goes from 0 to 1. The distance you're going to lift is 1 minus Y. Did it start full? Yep. 1 minus Y is this thing right here. That's the pattern. So first you label a Y, and then you're trying to figure out how much one of these weighs. So if you were to grab one of these with thickness delta Y, how much does it weigh? It weighs 40 times something times dy. And that something is going to be the area, so it's going to be pi. So you can really get to this step extremely quickly. Why is it pi? Because their cross-sections are circles. 40 times the volume of one of these, 40 times the volume of this, will be its weight. Okay, so in that spot, you get the integral from 0 to 1 of 1 minus y, 40 times pi, and then it's the square root of arc sine of y squared. And so your final answer would be 40 pi. So these are really short questions. And the point of them was to really practice the idea of setting problems up. So I'm not going to compute it. I'm just going to stop and go to the next one. Here we go again. Now evaluate. We didn't evaluate. How would you evaluate? Integration by parts. Okay. A laborer digs a hole. So I've mixed in a few unusual ones and some normal ones, but digs a hole that's 10 feet deep. And I've never looked at this question before. 10 feet deep. To the top, the hole has cross section as a rectangle, so it's 3 by 8. So this is 10 feet. This is 3 feet. This is 8 feet. And we're digging horizontal or cross section. So I did that. The dirt weighs 100 pounds per cubic foot. What is the work done to get the dirt to the top? It's the same thing. Same thing as the last problem in general, which is consider when they had to lift this layer to the top. And then separately consider what happened when they had to lift this layer. We'd like to add all those up. And separately consider what it's like when they had to add this layer. So for consistency, there's many ways you could label this one, but for consistency, let's just call this Y. So the two questions are, how far do you lift it to get it to the top? That's going to be 10 minus y. We're integrating from 0 to 10. And then how much does it weigh? Well, it's 100 pounds times the volume of this thing, which is going to be 8 times 3. So 3 times 8 dy. Done. It's fast. So look at the last one. Area of a cross section times the density times the distance lifted. We could talk about that one. There's a little subtlety there, but let's keep going. I want to keep the momentum. Another one. A spherical tank looks like this. It's resting on the ground, so its center is located r meters above the ground. The tank is initially empty, so there's something a little different about this one, and then water is pumped in from the bottom and is lifted up to a certain spot till the tank is half full. Find the work done. That only changes things slightly. So the starting picture is empty. The ending picture is going to have these pieces in here. So the biggest difference in a problem like this is instead of us lifting to the top, we are not doing that. We're lifting from the bottom. So that changes one main thing, which is instead of us saying, like we did here, 10 minus y, we actually just say y. That's the biggest change. So the distance lifted is y because we're lifting from the bottom. So anyways, the radius is r, so this is r. So I can already say the integral from 0 to r, and this was the part that was different. We're not saying top minus r because we're lifting from the bottom to that level. And now the rest of the problem is just like the previous ones. How much does that weigh? So we're going to say 9,800 times pi times the radius dy, and now we have just one thing to figure out. And sometimes students mistakenly put in r because they hear the word radius, but by radius we mean the radius of this. So your job now is to go on a little mission and label how far that is. And in order to do that, you need to know what points on the edge of that circle satisfy. And the center is 0, r. So the equation of the circle is x squared plus y minus r squared equals big R squared. And you'd like to know what x is based off of y, so x squared is r squared minus y minus r squared. And so x is the square root of r squared minus y minus r squared. So this is going to be the square root of r squared minus y minus r squared. And that's what's going to go here. Then when you square, the square root goes away. Done. So I'm focusing just on this one piece. The main thing that was different there was that you were lifting from the bottom up instead of from where you were to the top. So to me, the main difference here was this. The rest of them was like the other problems. Let's keep going. Here we have a tank. We're starting with it at a certain height. Tank is 6 feet long, 2 rectangular sides, ends are trapezoids, blah, 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 blah. The weight is this. It's filled with water up to a 1 foot level to lift to the top of the tank. Okay, here we go. This is y. We're saying given any horizontal slice there, we're going to lift that to the top. Top is 3. So we're going to do the integral from 0 to 1 because that's where the slices of water are, of 3 minus y. And then we're back to the same program. How much does a horizontal slice weigh? Well, it's 62.5 because they told me that, times the width, times the length, times the thickness. And the length is 6. And so on these problems, you typically are down to one last piece where you have to actually think and use your geometric reasoning. So we finished this problem by thinking about the pattern based off of y. How far is it all the way across here? There's a whole bunch of ways you can do that, but I would encourage you to just impose a coordinate system. And I've been getting lots of questions about this that really have nothing to do with calculus. You're going to have to think here. You're going to have to think, what is the equation for this side? Given the fact that you know this is 1, 0. Lots of students have asked me about why is this 1 if this is 2. Hopefully you can figure that out. Because it's 2 across, and I decided to put the origin in the middle. This point up here is going to be over 3 and up 3. How do I know it's over 3? Because it's from here to here. Up 3. So then you can find the equation of the line. The slope is 3 minus 0 over 3 minus 1. So it's 3 halves. So y is equal to 3 halves x minus 1. And you need the formula for how far it is from there to there. and then you're going to multiply times 2. That's the part that gets everybody. They're like, why do you multiply times 2? Well, because that's not the width. It's half the width. The width is all the way across. So we need to get this x. So you're going to say 2/3 y is equal to x minus 1. X is equal to 1 plus 2/3 y. And then you multiply that times 2 to get the width. So this is going to be 2 times 1 plus 2/3 y. Put that in there. Done. Let's look at, I haven't been checking my work because I've been pretty confident, but let's take a look at one here. Winter 2018. La la la, la la la. Here we go. 8y plus 12. 3 minus y. So let's see if I have that 8y plus 12. Is that what this is? So let's simplify this and see if we get 8y plus 12. So we get 2 plus 4/3 y times 6. So I'm getting 12 plus 8y, which is what I said. Okay, so there's our answer. Let's keep going. This is a hard, somewhat harder because you're pumping from the bottom, but it says assume you're building this pyramid. You're lifting from the bottom, but you now know the theme. This is y. If you want to call it y, which we usually do. And we're lifting, so it's 100 pounds. So I can already set up the whole thing. It's going to be the integral from 0 to 60. And the biggest weird thing is this is y and not 60 minus y. And that's because you're lifting from the ground to that level, and we're not lifting from here to here. This is not what the question says. It says you're building the pyramid, so you're lifting from the ground to that height. So you're lifting from here to here. But that is what y is. So we're almost done. That's as weird as this question looked. So you would say it's 175 pounds per cubic foot. And then we're going to do width times length, dy. But width and length are the same because it says it's a square. Square. So now we're down to the last step, which is just to label either the width or the length. So let's look at it from the side. How about? This is 100. This is 60. This is what we're calling W. This is what we're calling Y. Well, that's not quite similar triangles. You'd have to think about this a little bit, but if I made that triangle, this would be 60 minus Y. So now we have similar triangles. So if I was solving for W, I probably would say W over 100. So this side over that side has to be the same as 60 minus y over 60. So W is 100 times that. So W is 100 times 60 minus y over 60. That's going to go in for W, but it's also going to be L. So it's going to be that squared. So altogether, it's 175. The integral from 0 to 60 of y times 5/3 60 minus y squared dy. Success. Then it has, if you raise it from further down, assuming all the limestone section of quarry, that's 150 feet below the pyramid. Everything's essentially the same. You're just lifting it an additional 150 feet. So instead of lifting at y, it's going to be y plus 150. What was that? Winter 2022. Let's go take a peek. Winter 2022. See where this goes. Oh shoot, question A was just asking for the volume. I apologize, I misread the question. If it was asking for the work, I did it correctly. If it's asking for the volume, you're just computing the volume. So I apologize for that gaffe on my part. I was trying to make a video only on work and trying to only do work questions. So let's pretend, apologies on this, let's pretend this question had just been what's the work to create it. since I'm making a video only on work. I apologize for that, but I think I'm just going to leave it and continue on. Okay, this video is already too long, so I'm not going to do these other questions. I had something like this in my exam archive. Here's yet another one. Every single one of these now, you know that your job is to label, find the formula for the area of that, and then it's the same sort of thing as we've been doing. Same thing on this one. You're going to label this, find a formula for that radius. It's not r, it's changing. You have to find the equation of the circle first. But I want to finish with this because somebody was asking me this in office hours. This has an additional challenge. And the additional challenge is they don't tell you the equation for the parabola, so you have to find it. I told the people in office hours that if I were going to ask a question like this, I would give you a few more hints. So if you're stuck on this question, let me give you those hints. If you have a parabola that looks like this, which is on the end, and this is 0, 0, and this is 2, 5, and this is negative 2, 5, then you actually know that C has to be 0, because when you plug in 0, you get 0. And you also know that B has to be 0 because the vertex is at 0. So I'm not going to go through and do that long explanation. But the person who wrote this question was assuming students would know this. I think if I was writing this test, I would have just given that as a hint. And the reason you can then find A is because when you plug in 2, you get 5. So 5 is A. So this has nothing to do with the actual work piece, so I'm separating that out. So this parabola is y equals 5/4 x squared. And then the rest of the problem is like all the other ones we're doing. Take that piece, its width times length. If we call this y and we're pumping to the top, it's going to be the integral from 0 to 3 of 5 minus y. The density is 9,800. That's width times length dy. And then the rest of your problem will be labeling those two things. And we already know the length is 6. So the only problem is the width. And that's where this would come into play. The distance from there to there is what you get if you solve this equation for x. So if you take 5/4 x squared equals y, and you go x squared is 4/5 y, and you get x is the square root of 4 over the square root of 5 over the square root of y. That's that length right there. So 2 over the square root of 5 square root of y. 5/4, yeah. And then multiply times 2 because that's only the distance across here. So this would be 4 over the square root of 5 square root of y. So there's the idea. Apologies if I made any errors along the way, but that's a lot of problems I just did, and there's a lot more practice on my website if you're stuck on any of those. But I hope you're getting the idea when you look back at these. That was a rectangular cross-section, and you can see the setup. Here we had a rectangular cross-section. You can see the setup. Here's a rectangular cross-section. You can see the setup. There's a circular cross-section. You can see the setup. There's a rectangular cross-section. There's a circular cross-section. I don't know how to do any more than that. I just, without the video being super long.